Okay, we are continuing our discussion here of implicit derivatives. So we're looking at this function here, and it says find dr d theta. What they want us to do, and I'm just going to call it this, they want us to find r prime. Okay, so it could have been y and x, but in this case it's theta and r. You know, there's probably like an angle and a radius involved here, but we're not going to worry about what this is concerned with, or the shape of the graph or anything like that. We're just going to find the derivative, r prime, and we're going to do the theta treatment and the r treatment. So kind of keep it a little bit different. We're going to pretend theta is like our x, so we're not going to have to state theta prime, but we will state r prime, okay? Because they're asking for r prime in this question. So we're going to do first the theta treatment, and we're going to take the derivative with respect to theta for for all of these things, really. So we have 4/3, and we're going to power it down. So it's just a power rule derivative, 4/3 theta. And now 4/3 minus 1, which is, we write it as 3/3, because 3 divided by 3 is 1. So that leaves us with 1/3. So we have 4/3 theta to the 1/3 power. Then we have no other theta to take the derivative of, so we're good. Now we take the derivative with respect to r. Well, this derivative with respect to r there is 0. But here, it's very similar to what we already did. So we're going to say plus 4/3, because we bring the power down, r, and then we're going to subtract 1, which in this case is 3/3. So that's going to leave us with 1/3. But then I have to say r prime. And now that I've done that, I set that equal to, well, 1, when you take the derivative, whether it's with respect to x, y, theta, r, the derivative of a constant is 0. Okay, so now what we're going to do is we're going to take a look at 4/3 theta to the 1/3 plus 4/3 r to the 1/3 r prime equals 0, and we're going to isolate r prime. So that's pretty simple. We're going to move this to the other side. All right, so let's go ahead and do that. I'm going to have 4/3 r to the 1/3 r prime equal to a negative 4/3 theta to the 1/3, and then you should start noticing that you're trying to isolate r prime, so you need to move this out of the way. So what we're going to do is we're going to divide both sides by 4/3 r to the 1/3. Divide by 4/3 r to the 1/3. Just like that. Okay? And so what we do is we should notice what happens. The 4/3 end up canceling or dividing out. Okay? You end up being left with -1. And we end up with r prime equal to a negative theta to the 1/3 divided by r to the 1/3. Okay? Something like that. Now, since everything is to the 1/3 power and it's all negative, you could factor out the little negative in the front, and then you have theta divided by r all to the 1/3 power. Okay, so just a little bit of algebra techniques there, but nothing to it. I mean, it's basically the same thing. Okay, so that's definitely something that you could do when you're working on a problem like this. But I think we can look at one more example, so let's take a look. Okay, now in this problem, we're again trying to find r prime. All right, the difference here is that r is being multiplied by a square root of theta plus 1. So what we're going to have to do is we're going to have to actually apply the chain rule. I'm sorry, not the chain rule, rather, but we're going to, well, no, I'm going to take a step back. Okay, we are going to apply the chain rule, but for the theta portion. So we're again looking for r prime. Okay, this is what we're looking for. And what we want to do is we want to give this the theta treatment and the r treatment. And then we'll go ahead and find the derivative. So let's start by taking the derivative. All right. So I think the easiest thing here to do is to take the derivative with respect to r, and derivative of r is just r prime. So that's pretty straightforward, r prime. Now I'm going to write this theta plus 1 to the 1/2, just like that, okay? That's going to make it a little bit easier. Now, the next thing that I'm going to do is I'm going to take the derivative with respect to theta. So here's where we apply the chain rule. All right, we have, and I'm going to rewrite this real quick so you can see it like this. Okay, so now we apply the chain rule. We're going to have 1/2, bringing the power down. We have theta plus 1 on the inside. We subtract 1, which is really minus 2 over 2, if you will. So that's a negative 1/2. All right. And then we multiply by the variable that was sitting in the front, r. Okay. We're good there. Now we're left with the derivative of 4 with respect to r prime or theta. It doesn't matter. It's still 0 because it's a constant. Now our job is to isolate this r prime. And that's easily done here. Okay. So what we're going to do is we're going to kind of rewrite this a little bit. Okay. So I'm going to say here r prime times theta plus 1 to the 1/2. All right. And I'm going to move this stuff over here to the other side. Okay, so set it equal to, and it's going to be a negative 1/2 times theta plus 1 to the negative 1/2 r. Okay, looks something like that. Now what I'm going to do is I'm going to rewrite this so that I can get my negative 1/2 in the denominator. Okay, so I think I'm pretty set on writing it back as a square root. I think that's okay. All right, so negative 1 over, and then it's a 2 in the bottom, multiplied by the square root of theta plus 1, just like that. Okay, and then this r comes back into play, gets multiplied by the negative 1, so it actually just becomes negative r. Now I'm ready to multiply it by the square root, or divide it rather, by the square root of theta plus 1. But that's the same thing as multiplying by the reciprocal, which is 1 over the square root of theta plus 1. So this makes it actually really nice. Hopefully you see what's going on here now. When we multiply this over here, we're going to get negative r times 1, negative r in the numerator. But in the denominator, these two square roots of theta plus 1 end up canceling or getting rid of the square root, so we end up with 2 times theta plus 1, something like that. And that's about it. I mean, this right here is our r prime. Okay, so again, if you had a value for theta, you had a value for r, perhaps an angle and a measure of a radius, then you could find the slope of the tangent. Okay, so nothing really to it. So just another set of implicit differentiation problems. So, as always, I hope this video was helpful, and remember, like and subscribe.